somewhat debatable too. It's a kernel on which a lot of operating systems are built. And the difference between a kernel and an operating system is also largely semantic, but essentially the kernel interacts between the software of the operating system and the hardware, and the operating system is an interface between the user and the hardware. Not super important. What is important is that you will hear and encounter a lot of different flavors of Linux operating systems, because different people have decided that different priorities are important when building their distributions. So they will distribute a particular package of tools alongside the Linux kernel to fulfill a particular role. Some of the big families that you'll see are Debian, which includes things like Ubuntu and Kali, which you will both interact with quite a bit, as well as Raspbian for like Raspberry Pis. And Red Hat Enterprise Linux is another main distribution. That one you will probably interact with CentOS in your time at RIT quite a bit, but Fedora is another distribution of a RHEL family. These are sort of families which have similar ecosystems of like packages and such. I'll get into that a little bit more later on. Arch is something that a lot of our members tend to use when they want to run Linux on their own machine, because it's a very bare bones install, and it lets you control just about everything. And Alpine is something that you probably won't interact with very much, but you will run across. It's usually used for small container applications. It's very lightweight and very minimal. So I mentioned users, some of the club members like running Arch because of the control it gives you. Linux is often about finding balance, because you are allowed to do just about anything. You can install whatever programs you want onto the operating system, control just about every portion of what loads your, what manages your credentials, what loads on boot. You can control everything in very fine detail, much more than most other distributions, which intentionally, or most other operating system families, which intentionally put things behind barriers so that you don't hurt yourself. So one of the things that comes with this control is Linux often gives you too much control and the ability to hurt your experience by making decisions that you thought would be good. So that part of the balance with Linux is finding often which distribution gives you the control that you would like, and also managing each thing that you install at the level of specificity that won't confuse you or break things. Also on the note of breaking things, one of the great parts about Linux is that pretty much everything you deal with is free or open source. So there are a lot of very nice package managers. Every distribution seems to have its own. The four I mentioned earlier, Debian-based things usually use the aptitude or apt package manager. Red Hat distributions usually use Yum. There's also a dandified Yum, but that's for Fedora. I have Arch uses Pacman, and Alpine uses APK, which is similar to what Android uses. They all have different package managers, which allows you to install tools that are publicly hosted in repositories for free for your use as you please. This is great because who doesn't like free things? And it allows us to have like a community and an infrastructure that you can spin up whenever without any cost. The problem with this is that it's entirely reliant on those packages being maintained and developed by the community. So if those packages have vulnerabilities, someone needs to patch them, and often they are not paid to do so. So you're reliant on somebody taking the time out of their day to fix these things. Sometimes there are teams that develop them. There are plenty of foundations, which are nonprofits, which host some of the major packages like the Apache web server. But just know that a lot of the infrastructure is built on the community. So as soon as code is bad or it is not maintained, it is a liability. That said, the open source community is very strong and continues to grow stronger. So it's not a major concern most of the time, especially if you're working with any major projects. Another of the things about balancing Linux, you can give it as many resources as you need. It is such a lightweight operating system family that you can run it on next to nothing, or you can run it on a massive server depending on what you need, and it will chug along just fine. So one thing before I get into any of the specifics on interacting with the Linux environment, every time anyone has ever presented on an intro to Linux, they have or should have mentioned the documentation and reading the manual. Linux most of the time ships with and sometimes is and generally can easily install a utility called man, which allows you to read documentation on pretty much anything. You'll see on the slide there's 9 different manuals of which there are many pages for many tools. So if you are trying to learn how to use a tool, this is the place to go. You can also Google, of course. You will find a lot of the same resources online that you would find from the man pages. It's just good to know that this is here. Even as you get more comfortable with Linux, there's always something you can learn from reading the manual pages. And I know one of our alumni, shout out Micah Martin, spent a lot of time reading manual pages and got very comfortable, very knowledgeable about a wide array of tools in Linux, and was able to use the information he learned from the man pages to develop some really cool red team tools that we use to this day. So read your manual, kids. So now we're going to talk a little bit about navigating the land. So the first thing you want to do is generally, if you're on a new system, you want to figure out your identity. So who are you? Usually you'll probably have typed in a password to log in as user, so you'll probably know that one, but it's good to know, who am I? What groups you're in? So what are you? What are you allowed to do? Where are you? The Linux file system is a tree of directories. So you may want to know where in that directory tree you are located. If you run the pwd command, you will find the path to the location which you are currently running out of. I'll get a little more into paths later on. They're sort of intimidating, but trust me, it'll become second nature to you. You also might want to know what host name you're on. This is sometimes for networking purposes, but just generally a good idea. And you will notice the IP command. There's a lot of different, there are a few different ways to get your networking information. I think the preferred one these days is IP, given its wide range of flexibility. In the past, ifconfig was the command used, but these commands give you information on your networking interfaces. I used the brief option, which limits it to IP addresses, just so for succinctness, but it will also tell you information on your hardware interfaces for networking. These are important for kind of figuring out where you are in a network and what things are around you, what sort of address space you have access to from that particular machine. 2 other things that you might want to do when you're trying to figure out what's happening around you is check out running processes. There are a lot of ways to do this. I chose PS because it's one of the more basic. The F option shows process trees, and the other options are just generally everything that's running. Running processes are very good when you're checking running processes. Very good when you hop onto a machine for the first time, especially in like a blue team situation. But you kind of want to know what's happening around you. Just another part of your bearings. And another way to check networking information, commands like netstat and ss, they will tell you what sockets are being used. We'll get into what a socket is later, and different things that are happening on your machine as far as open connections and all of that. This is a lot. I'm sorry. It's just that the Linux environment is a very scary place. So hopefully you can come back to these slides if you are lost at all at some point, and you can reference the things that are seen here so that you can solidify this, because no matter how I try to break this down, there's going to be too much. Okay, so now we're going to talk a little bit about navigating directories. And there's a large wall of text here, so I'm going to go through each line one at a time. So first, we create a directory. We made a directory. It's called directory. You can see in the top right, if you kind of want to follow along, I took a screenshot after this was all done of the tree created during this process and where we're navigating, so you can kind of see where we go through. So we first make a directory called directory. Then we make two subdirectories inside of directory, both of these using the make dir command. That is the utility which makes a directory. Then we will change our directory to the subdirectory. So you see we have cd, the first directory, slash the subdirectory. This is the general way you navigate around folders in Linux. You change directories based on the path, and you can do paths relatively, which you'll see in a second, and full, like absolute paths based on the file system root, which I will talk about on the next slide. So here, you notice we use dot dot. Dot dot is the parent directory of the current directory you're in. So as you'll see, it's kind of like a tree. And if you are further down the branch, you can go to dot dot to get to the bigger branch that you just came off of. So we were in directory subdir. We are now in directory. And you can see in the prompt that the directory we are in is in red. So now we can run ls, which will list the contents of the directory. And there are plenty of flags which you can pass to ls to get more information or organize the information differently. That's a command you will definitely become familiar with. It's so familiar that sometimes I run it without thinking about it on a directory I just made, which is very empty, clearly, but we all do it. It's a very great utility. You will definitely become familiar with it. It just allows you to see what's in the current directory you're in. Next, we're going to change using the local path from directory to the subdirectory another. So we've gone directory subdir, gone back to directory, and now we've gone to another. You can see that we are now in the another, and we're going to just change to our home directory. This is another one of the special characters in the shell environment. The home directory is represented by tilde. You can also do this with just leaving the cd without a argument for a directory to change to, but to be more explicit, we use the tilde. And another feature of the shell for navigating around, you can use the dash to go back to the directory which you were just changed out of. So we were in another, we went to our home directory, and now once we run cd dash, we will end up back in our directory another. Okay, so these are a couple things that I learned about this summer. They're somewhat new to me, and I'm just wanted to throw them in here for anybody who's watching who's pretty familiar with Linux in case they didn't know about them. The bash shell, which is one of the most common shells, you'll probably end up dropping into a bash shell almost anytime you log onto a Linux system, has two keywords, pushd and popd. If you don't already know about it, you will learn about the stacked data structure in computer science classes somewhere. But what the pushd and popd keywords do is allow you to add a directory to a stack and then traverse directories from the stack. So you can add a directory to the top of the stack, and then when you pop, you'll go back to the directory that was at the top of the stack. Just threw that in there in case somebody was bored. Now we're going to move on to the landmarks, some of the important directories that you will encounter and should probably get to know. Slash is the file system root. This is the base of the tree, where the root starts. So everything sprawls out from that. The etc directory /etc is for settings and things. Usually you'll find configuration files for installed services and other utilities, some general system and operating settings, etc. It's generally where you're going to find configurations. Anything that is bin or sbin, the star character, the asterisk, is a wildcard that matches all characters. So usually you will use it to describe a pattern of string, like a pattern of characters, which matches everything with whatever you're specifically looking for. So any bin or sbin directory generally contains executables. The executables in the sbin directories are usually for administrators and will probably require administrative privileges to run. This is mostly useful for using the absolute path as opposed to the relative path of executing them. Not to confuse anyone. I'll get a little bit into the environment variables later on. Proc is where process metadata is kept. Usually you aren't going to spend too much time looking at it, but it is good to know that it exists. It's a special directory. It kind of behaves differently than the other ones in that most of the files are sort of pipes or metadata on the program. You don't necessarily control them or interact with them very often. Var log is generally where log files are stored by services and other installed programs. That's a good place, especially as a blue teamer, to look. Everyone who's ever red teamed has always told blue teamers, look at your logs. You will find so many things there. So knowing that /var log is a place to look is very important. /home is usually where user home directories are. So if my user was Radan, then the home directory would most likely be found in /home/Radan. The /root directory is the home directory of the root user, and the mount directory is for mounted devices like flash drives or really anything else that you can plug in and mount to the operating system. So we're going to get a little bit into file permissions before we talk about the root user. File permissions are sort of complicated. Every single time I've had them explained to me at the beginning, I was confused until I sort of messed with it myself, and then it started to make more sense. So the basics: files are owned by a user in a group, and they have 3 permission modes which can be set, which are read, write, and execute. These permissions are granted to people on the machine and by the owner level, the owning group level, and other users. So you'll see on the right, there's a little chart that sort of describes this. The user, the group, and other users are granted all 3 or not granted any of those permissions. So I guess that's not a great way of wording it. You can control granularly whether permissions are granted to the user, group, or other users. You can see these permissions if you run the ls-l command. The -l flag lists the files and their and some information on them on one line. You can set the modes with the chmod command, and this is an octal number. So it's set in 3-bit increments. You can kind of see the 111, 101, 100, I believe is what that says. My screen's kind of covered up. But that is an octal number. 755 is what it comes out to. This is one of the ways of setting permissions. There's a lot of ways of setting permissions. The chmod command is somewhat flexible in how it is done. But I'm hoping that the picture helps you see the different ways of describing the user permissions on the files. The owners are set with the chown command, and usually you separate them with a colon. When you're running this, you can also base this off of other files if you want to match file permissions on a different file. 3 other special things about this. There's another another 3 bits which can be used to set 3 different properties. They're kind of advanced, so I'm not going to get into them in depth. I'm just going to leave them there in case you want to come back to them and reference them. If anyone has any questions about this, feel free to ask. I'm hoping either I will be able to see or answer these at some point during the presentation, or somebody else in the chat can as well. So we're going to talk a little bit about the root user, and then we talked about permission. The root user is the king and generally can't ignore file permissions. There's some things that the root user themselves cannot ignore, but usually they can undo the things that prevent them from being able to ignore file permission. So the root user is the most important user on the system. It generally is responsible for managing the permissions of the other users and creating the other users so that you can not only use the root user. There's a lot of security caveats with only using the root user, because that is if everything is running as the root user, I suppose I should talk about that. If everything is running as the root user, anything that takes over that process will execute things as the root user. The way Linux handles permissions with running processes, the process, it runs with the level that the user who invoked it at that time has. So if a process is running as a root user, it runs with all the permissions of a root user, and anything that that process does, it will act as root doing. If there's something incorrect with what I have said, somebody please call me out. I don't want to mislead any of the kiddos or the non-kiddos either. Something to note, the sudo utility allows users who are not the root user to act as if they were the root user. This is a sort of way to get around running everything as the root user, but it also is often better, especially when dealing with services, to handle things with file permissions, although that is much more difficult. Usually you create users and then grant administrative users sudo privileges. So now we're going to get a little bit into interacting with files. There are so many different ways to do this in the Linux environment. I kind of picked the most, I don't want to say important, but some of the more common ones that are used. So once you have access permission at the permission level to interact with the files, with a file, you can use these commands to sort of get different bits of information. So cat will print out the contents. Here I ran cat on the /etc/password file, which shows user information based on the root, whether or not their shell is whoops. There, I probably shouldn't go into all of the different pieces of this file. Just you should know that it contains user information and different information about what that user is set up to do, such as what shell it runs and where its home directory is. So cat is a utility for printing the contents of the file. File is a command that will tell you metadata about the type of the file. The MIME type, which I forget what that's an acronym for, but essentially, like, if a file is ASCII text, it will tell you this is ASCII text. If it's a compiled binary, it will tell you this is a compiled binary. If it's an image, it'll usually tell you that as well. Stat is more metadata on the file, but more related to the file system, so you can see data on when it was accessed and changed, as well as some information on the actual file system's handling of the file. The grep command is one of the most used commands probably ever, because it's so useful and powerful. It is used to perform pattern matching on streams of data, or files. So you can look for example, I looked for my username in the password file, and it matched, and usually the color highlighting is turned on to make it nice and easy to see what matches are being done. But you can run grep on different streams of data to match pattern, and it includes regex, etc. It's very useful for cutting down output into exactly what you want, and is usually included in some chain of commands, which we'll talk about later, between different processes. Find is another very nice utility. It allows you to find files based on different attributes. You can do it based on file type. You can do it based on name. It's just a generally useful tool for locating where something is. There are a couple other commands to do that. such as the which or where command, which will tell you where a binary that is on your path environment variable, I'll talk about that in a second, is located. However, find doesn't worry about that. Find will take a root directory and it will traverse the tree to look for whatever you have told it to. And often this includes a lot of red text that says, I don't have permission to look here. But if you run it as root, you don't have that problem. Less and more allows you to scroll through the file. This is very helpful on some windows which you don't have the ability to scroll with your mouse. Some terminal windows don't have that privilege, and if you actually want to be able to look at the full contents of the file, less and more are pretty essential for being able to look at the entire file at your own pace. Tail and head are also very useful for getting the beginning or ending of a file. I forgot to scroll through the screenshots. There's an example of more. Here is an example of tail. That's the last few lines of the password file. Very useful for making sure that content is being put into the file in the way that you mean to. I generally use tail a lot more than I use head. One of the more powerful tools on this little list here is Vim/Nano/Emacs, which are all text editors. I personally prefer Vim. There are many people in all three of these camps, and they will fight wars about it. They're all pretty useful utilities. Usually, I would recommend picking one, getting comfortable with it so that you can utilize all of the tools and powers within that and not have to constantly switch in your head between them. I prefer Vim. It's very nice. They all do very nice things. Word count is a tool for getting data or information on the contents of the file. You can count lines, you can count characters, you can count all sorts of things. Very useful if you're testing output and making sure that things are running at a proper clip. Usually I have run this on log files to make sure logs are being added properly. And there is touch. I didn't include a screenshot for that because it's really kind of hard to show what it does, but it updates the timestamps that you would see with stat. And usually how I see this command used is to make a new empty file. So now that we know how to interact with files and traverse directories, you'll be happy to learn that Linux is essentially all files. So using the tools and techniques that we have discussed so far, you should be able to poke around and prod around and learn just about anything you want to about the operating system. Directories are files, configurations are all files, executables, they're just files. Mounted device, they're kind of files. Sockets, which are network, a software interface which exposes the machine to the hardware that allows for networking. Those are also files, believe it or not. Files, still files. Even processes get their own files. So everything on Linux ends up being a file at some level in some way. Shout out to Josh who noted yesterday that, well, technically syscalls aren't files, but whatever. There will always be a semantic debate about every broad claim such as this. However, in general, everything you interact with on Linux can be dealt with as a file. This is very handy. It allows you to run grep on just about everything, which is why the file utilities that I mentioned on the previous slide are so useful, and you should familiarize yourself with them. The environment. I've mentioned this a couple times. There are, in many shell environments, there are things called environment variables. You can see them all if you run the env or print env command, depending on which one is installed on your machine. They are very handy. I've mentioned a couple times the path variable. That is an environment variable that is initialized whenever you start your shell. It tells the shell interpreter which directories it can look for executables so that you don't have to type in the full path. There are many uses for these, so I'm going to go quickly through how to set and export them to the environment. So you set with the name and an equal sign, no spaces in between, and the value. There are a lot of ways to do this. I use double quotes here because it's a very simple example. And once you have set the value, you can then export it to the environment. This allows it to be accessed from within programs that are not directly your interpreter session in the shell. The shell is just the thing you run commands in. You can see one of the environment variables in the screenshot at the top is the shell, which has been bash. And as I mentioned before, bash is probably the most common shell. So normally, if you just have a variable in a bash environment, it's only accessible within that particular process. However, exporting it allows any processes from your session, your bash session. So like if I start a bash script or any other program to access that variable. These do not persist past your session. Once you close your terminal shell, they will be gone, poof, forever, and nobody outside of your session can access them. However, you can, if you would like variables to persist, throw them in your profile files, which is something we'd probably talk about in Advanced Linux Week, to save them permanently and and add them to your environment whenever you start a new session. And now we're going to talk about one of the most useful tools, what makes Linux very appealing in some ways from a server perspective, which is SSH, also known as Secure Shell. It allows you to start a new shell session on a different box that is running a SSH server. Very useful for accessing things remotely, because it's like you're just typing on your own machine, but you're getting things done remotely. There's not too much to talk about what it does. It's I think relatively straightforward. If you have any questions, please ask them. One of the great features of SSH is the use of SSH keys. You can generate them using various different cryptographic techniques. There's usually the three most common are RSA and two different variants of elliptic curve keys. What this allows you to do is essentially have a password that is remembered by the machine and not your brain. So instead of typing in a password, as you see in the screenshot at the top, to gain access to the remote box, you will use the key, and the key will act as your password, essentially, allowing you to access the remote host. Very useful. This is especially useful for things like GitHub and GitLab and whatever remote Git things you're using. Yes, use SSH keys. They're very nice. But also, when you're blue teaming, make sure you don't have SSH keys sitting in your trusted or your authorized keys files, because then red team will sneak on in. Just a little tip there. We'll get into that probably more when we talk about blue teaming. Some other useful tips. This is kind of like one of my favorite parts about Linux, is there's just so many useful tidbits and tricks that you can do to save yourself so much effort. One of the most common and fundamental is piping and redirecting. You can redirect the output of any command to other commands. Sometimes this gets a little complicated if you need super user privileges. We won't get into that now, but some of the basics are piping. So you'll pipe the output of one command through another command, usually to filter out some unwanted data, etc., with something like grep, or generally to feed it to another program if the first command feeds data to the other program. You can also redirect your output to a file with the caret, the right pointing angle bracket, and you can do the opposite, get input from a file with the left angle bracket. I see the right more common than the output version more commonly, but both are valid. If you are getting a lot of errors in your script and you don't care about that, you can put the second output stream of standard error to dev null, which is a device that's just constantly 0, so that you don't have to see your error message anymore. And you can also run commands and save them to a variable type thing with backticks, $, and parentheses combinations. All these you will definitely become more familiar with as you use them. You don't need to remember all this right away, of course. Please look back at the slides if you're confused about things. Um, Keyboard shortcuts. There's a lot of keyboard shortcuts that are generally standard across shells. Control D is usually exit. This is very handy. Typing exit, not that much work, but hey, if you do it a lot, you can save yourself some time here. Clearing the screen, something I do almost compulsively. I used to have to type clear all the time. Now I learn you can just type Control L and you clear the screen. It's great. Control C, something you will absolutely have to use at some point in your life, is for stopping a command. Sometimes this is because, oh shoot, I forgot to run it with these flags. Sometimes you realize that there's something wrong with it. Sometimes it's hanging. Regardless, you might want to run this to stop the command or input this keyboard shortcut. Control Z is similar. It will suspend the current process, at which point you can either type FG to foreground it or BG to background it. This process will be suspended until you do either of those things or close your shell. There may be other ways to unsuspend it. Those are the main ways I have seen. Control R is another useful one that I often forget about, but allows you to search through previously run commands. And it will make an appearance again on this slide, which is all about previous commands. Many shells, especially Bash, will keep track of your history, which is very useful because it allows you to press the up arrow a lot of times and rerun commands that you've already ran instead of typing them out all over again, which is quite often a huge pain. Here are some different ways to do that even more efficiently than pressing the up arrow a bunch of times. You can, as I said previously, search through your command history with Control R. You can rerun your previous command with bang bang. Usually this is done with sudo bang bang. Side note, I don't know why we call exclamation points bangs, but it's way easier than saying exclamation points. So that's a bit of lingo you'll probably pick up. Sudo bang bang runs it as the super user. So many times you'll probably run something as your normal user, forgetting you're not root or forgetting that it needs super user privileges. Then you'll just run sudo bang bang, save yourself the time of typing out the whole thing again or pressing up arrow, blah, blah, blah. Bang 12 will run the 12th command of your bash history. So any number there, as long as it's in your bash history, if you run it that way, will run that command from your history. If you run, for example, bang SSH, that will rerun the last command that you ran starting with SSH. This is obviously not just for SSH, but for any other command. If you want to rerun a command replacing things because you accidentally made a typo, etc., you can run the command with caret this, caret that, where you replace this with that. Now, those words probably are slightly confusing, but if you try it out a few times, I'm sure you'll pick it up. And something that's useful when scripting especially is $? Which just gets the variable from the shell on whether or not the previous command returned successfully or not. Probably something you weren't going to have to encounter until you start writing any scripts. Just something that's useful to know. Again, look back at these slides if you want to. Most of this is a lot to take in at first. You'll probably be able to come back to it after you've sunk your teeth in a little bit and get more out of it the second or the third time. And this is possibly the single greatest feature that is so common in the Linux shell. The tab key is generally used for auto-completion. And boy, is it nice, especially when things have really long names. So I find myself pressing the tab key almost incessantly whenever I'm in a Linux environment, just to save myself some time and make sure I know what's available to me. Just make sure you don't have your terminal bell sound on because the people sitting next to you will probably get really annoyed really quickly. There are two other talks given by people who are much more knowledgeable about Linux than I am in the past. As I mentioned before, Micah Martin, former president of the club, and last year's competition architect, Jack McKenna. Both of them really great people, way smarter about Linux than I am. So you should also watch their talks if you want to learn more. They're pretty awesome dudes. If you message them on Workplace, they will probably get back to you. Yeah. So if you want to learn more, go ahead and check them out, or their talks out. The links are there. Are there any questions? I'm now going to attempt to check the 3 different sources that could possibly have questions to see if I can see any. Oh boy, there are questions. Some of these are about the education portion. If anybody on the e-board has seen any questions in the chat and want to help me filter through these, go ahead and pop them in with the voice. Thank you, Brad. Shout out to Brad for answering so many questions already. Absolutely legendary, my friend. Thank you. Brad is another awesome dude who you can ask questions. He knows quite a bit. There are a lot of those people around here, you'll find. I didn't know anything about Linux 3 or 4 years ago when I started coming here. And now I'm sitting here giving a talk about it and trying to be as simple as I can, because there's just so much. All right. Let's see, is there a Twitch questions that I haven't seen? Oh boy. Where is the Twitch window? Does anybody see any questions? John, do you see any questions on Twitch?
I don't.
Okay.
If anybody, if anybody has questions though, feel free to hit us up in the Discord, on Workplace, on demo help questions, anywhere. And if you feel like you're not getting your question answered, feel free to reach out again or in some other location. Don't be nervous about asking questions. That's what we're here for.
Yes.
Also, if you didn't understand any of that, that's okay. Please don't be scared away, because it's okay not to know stuff.
The first time I sat through a intro to Linux presentation, I don't think I understood like 90% of it. Make sure to keep looking back through the slides. There are many references online. There are many references as people in the club. There are 3 sets of slide decks and 3 now talks on Linux intro here on our YouTube channel, and also I think on Twitch. There's plenty of resources. Don't let it overwhelm you. It's fine. It's fine.
Alrighty, if there's no questions, can you hit the last slide, Dan, so Emmanuel can present his?
I think this is the last slide. This is the last slide. All right.
It's all you, Emmanuel.
Okay. Yeah. So the flag submission website is flag.retsec.cloud, not club. And you have to register with your RIT email. And the challenge link to get the VM is at that week1-linux.ret.club. And the flag format is usually RS and whatever is in between those curly braces. And for extra points, you guys can submit to me a one-page documentation about how you solved the challenge and extra research you did. And at the end, you can also do a quick 2-minute to 3-minute talk next week. So yeah, and I will be in Discord if you guys need any help from me. And you can also ask the other e-boards for help too.
Alrighty, with that being said, we're going to go into some demo time. We'll be back at I'd say 2:05 for research. We have a bunch of research talks, so we're going to try to be super punctual today. A lot of really good research talks. If you can't make them, they'll probably be on the YouTube. I believe everyone's being streamed this week. So yeah, if anyone has questions during this time, please reach out. We're going to be in Discord hopping around working on the demos. The demo is public, I believe, so please feel free to do the demo if you're not an RIT student. Emmanuel worked hard on making these challenges, so yeah, show him some love and do the challenges. All right, with that being said, we're going to go to demo time.